Hello friends, welcome to Engineering Funda family. In this video, I'm going to explain you Hamming code, and after watching this video, I can give you guarantee you can be able to solve any problem based on Hamming code. So before we proceed with this video, let me show you how many things that I'm going to cover in this video. So first, I'll be covering what are the basics which is there with Hamming code. After that, I'll explain you how much minimum redundancy that we need to add in Hamming code. So for that, this condition is there, and that condition that I'll explain you by practical example. Then I'll explain you how we can provide position of that redundancy bits and message bits in Hamming code. That is even I'll be going to explain you by practical example. Then I'll explain you how we will be calculating that redundancy bit in Hamming code, and that will be resulting into code word of Hamming code. So that even I'll be explaining you by one practical example. After that, I'll be solving two interesting examples over here in which I'll be considering data bits, and based on these data bits, I'll be generating Hamming code. And then second example will be there that will be based on how Hamming code can resolve error as if you receive Hamming code with error. So here I'll be detecting error as well as I'll be correcting error over here using Hamming code. So all those things that I'm going to explain you along with practical examples. So let us see first how many basics are there with Hamming code. So this Hamming code that was initially given by R.W. Hamming, and based on his name only, this name of code is Hamming code. This code is used for error detection and error correction. In Hamming code, code word will be data bits and parity bits. See, along with data bits, we will be adding redundancy. That redundancy will be parity bits, and based on this combination, code word will be generated, and this code word can detect the error as well as it can correct the error. It is represented by n comma k. You should know, my dear students, it is represented by n comma k code, where n is total number of bits. Total number of bits means total data bits plus total parity bits, so that is n, and k is message bits. Message bits is k. So you can say parity bits will be total bits, that is n, minus message bits, that is k. So parity bits, that will be n minus k. Now here you must be having question like, when you forward the message, along with that you will be adding redundancy, that is parity bits, right? So what should be the minimum bits which is there with parity bits? That should be the question. Like here we are forwarding data, along with data we are transmitting redundancy. So first question that should be what? How much minimum redundancy that we need to add over here? So for that you need to see this condition. See, parity bits should satisfy this condition, otherwise Hamming code cannot be constructed over here. 2 to the power p, that should be greater than or equal to p plus k plus 1. Let me give you one example. For example, as if I say we are having message bits, that is k, and that is equals to 4. So for k is equals to 4, let us try to understand how many minimum parity bits that we need to have. So here 2 to the power p, that should be greater than or equal to p plus 4 plus 1. So you can say 2 to the power p, that should be greater than or equal to p plus 5. Now we need to substitute value of p, and based on that we need to see whether it is satisfying this condition or not. So here first what I'll be doing is I'll be considering minimum value of p, that is equals to 1. So what will happen here? 2 to the power 1, that should be greater than or equal to 1 plus 5, that is 6. So this condition is false. So you cannot choose redundancy bits as per 1 bit. So let us increase that by 1. Let us say p is equals to 2 here. So here what will happen? 2 to the power 2, that should be greater than or equal to 2 plus 5, that is 7. So 4 cannot be greater than or equal to 7. So this is even false condition. So now let us increase redundancy by one more bit. So let us take p is equals to 3 bits over here. So what will happen? You see 2 to the power 3. So 2 to the power 3, that should be greater than or equal to 3 plus 5, that is 8. So 8 is equals to 8. So you can say this condition is getting satisfied. So minimum value of p, that you can say minimum value of p, that is 3. So based on number of redundancy and based on total message, we can have Hamming code over here. What is Hamming code? Hamming code is n comma k code. Hamming code is n comma k code. So here if you observe, k is 4 and n is total bits, that is k plus p. So you can say here n is 4 plus 3, that is 7, and k is 4. So particularly right now we are talking about Hamming code with 7,4 code. So right now we have understood like how many bits that will be there in terms of parity bits with message bits and how that code will be there, right? Now let us try to understand how position of parity bits and message bits will be there. So here same example that I'll be considering as per 7,4 code, right? I have explained you how it is getting constructed. Now let us try to understand how position is there with this. So to understand position, first of all you need to understand how parity bits are there, right? So if you observe, we are having total how many parity bits? 4 parity bits. So first parity bit, that position will be as per 2 to the power 0. Next parity bit, that will be having position as per 2 to the power 1. Third parity bit, that will be having position as per 2 to the power 2. And next parity bit, that will be having position as per 2 to the power 3. So this will be having position 1, this will be having position 2, this will be having position 4, and last one will be having position 8. So here P1, P2, P4 and P8, that is how I'm giving name to this parity bits. And here you see we are having 7,4 Hamming code. So I'll be placing this parity bits as per P1 is having first position, P2 is having second position, and P4 is having fourth position. But we don't have 4 bits. Here we are having how many parity bits? You see we are having 3 parity bits. So here you don't need to have P8 over here, right? Now here message bits. So message bits are how many? You see message bits are k, that is equals to 4, right? So here as per n comma k code, message bits, that is k is equals to 4. So that will be positioned as per you see D7, D6, D5 and D3. So this is how 4 bits message that we will be having over here, right? Now let us try to understand how we will be calculating those parity bits. See message bits that we will be having, right? These message bits D7, D6, D5, D3 that we will be having, and that message bits that we will be transferring on the channel. Question is there based on how to calculate parity bits. The reason is parity bits will not be given to you, that we will have to generate over here. So how to calculate parity bits? Let us try to understand that. So here first let us see how we can have a calculation of P1. So P1 that we need to calculate as per check 1 bit and skip 1 bit. Again P1 calculation that is there as per check 1 bit and skip 1 bit. So here P1 that will be this, and after that we need to skip 1 bit and check 1 bit. So D3, then skip this D5, then skip this D7. So for P1 check 1 bit, skip 1 bit, and here we need to perform XOR operation. So P1 is D3 XOR D5 XOR D7. Now when you want to calculate P2, in that you see this is P2. So we need to have check of 2 bits and skip 2 bits. So you see we need to check 2 bits. So here with P2 we are having D3 with 2 bits. So D3, and we need to skip 2 bits. So we need to skip these 2 bits. So then we need to check another 2 bits. So you see D6 XOR D7, that is how it is there. So for P2 check 2 bits, skip 2 bits, right? Check 2 bits, skip 2 bits. That is how we need to find it. And when you want to calculate P4, so you see from name itself, we need to check 4 bits and skip 4 bits. So along with P4, how many 4 bits are there? D5, D6, D7. So D5, D6 and D7, that is how it is there, right? So once you do XORing like this, you'll be having this parity bits, right? And this is what I'm calculating it for even parity. This is what I'm calculating for even parity. As if question is there based on odd parity Hamming code, then you just have to invert this, right? So after calculation of this, just reverse the polarity of this. So that will gives you odd parity, or you can say by XNOR operation you can have this, right? So I'm just calculating this for even parity. Similar thing that you will be having with odd parity, right? Now here let me give you one example, so that will gives you more clarity regarding how we can have generation of Hamming code. So here we have been given with 5 bits of data. So let me mention that data over here. K is equals to 5 bits over here, and data, that is this. So that is 01101. Now we need to form Hamming code over here. So first of all, we need to understand how many parity bits that we need to have. So for that, you should know the condition, right? Condition of parity bits, that is 2 to the power p, that should be greater than or equal to p plus k plus 1, right? So here 2 to the power p, that should be greater than or equal to p, and k is how much? 5. So 5 plus 1, that will be 6, right? So this is what the condition that we need to have, and based on this we can have minimum number of parity bits. So here let us have minimum number of parity bits by taking some assumption. So let us take p is equals to 1 first. So for that, what will happen? 2 to the power 1, that should be greater than or equal to 1 plus 6, that is 7. This is false condition. So take p is equals to 2 now. So for that, what will happen? 2 to the power 2, that should be greater than or equal to 2 plus 6, 8. So 4 cannot be greater than or equal to 8. So this condition is also false. So let us take p is equals to 3 now. So in that, 2 to the power 3, that should be greater than or equal to 3 plus 6, 9. So 8 cannot be greater than or equal to 9. So this is also false condition. So let us take p is equals to 4 now. So here what will happen? 2 to the power 4, that should be greater than or equal to 4 plus 6, 10. So 16 is greater than 10. So you can say this condition is getting satisfied. So I can take minimum value of p, that is equals to 4. So p, that can be equals to 4 over here. That is what minimum number of bits that we have, right? Now let us try to understand how exactly we can have position of bits, right? So here we are having total 4 bits with parity bits. Now we need to have position of it. So I have explained you how to do position of these bits. See, p1, that will be having 2 to the power 1, 0, then 2 to the power 1, then 2 to the power 2, then 2 to the power 3. So in total 4 bits are there. So I can say this is 1, this is having position 2, this is having position 4, this is having position 8. So I can say this is p2, p4 and p8. So let us have position of this parity bits over here. So here I'll be having p1, then I'll be having p2, then I'll be having p4, and then I'll be having p8. So these are the positions of parity bits. And message bits are having how many size? 5 bits, right? So this data that is given to us, but first of all, let me have a position of that. So those 5 bits will be D3, D5, D6, D7 and D9. That is how message bits that we will be having, right? Now you see what I'm going to do is I'm going to take this data. So that is 01101. So let me write that data over here. 01101. That is how data is there with us, right? Now we need to calculate what are those parity bits. What is P1, P2, P4 and P8. Once you have that, you will be having code word, right? So for a calculation of parity bits of P1, what you need to do? You will have to check one bit and skip one bit. So P1, that is having this skip, this check, this skip, this check, this skip, this check, this skip, this check, right? So we'll be having this D3, that is 1, then skip 1, so this will be 0, then skip 1, so this will be 1, then skip 1, that will be 0. So this will be 1 XOR 0, XOR 1, XOR 0. So two ones are there, so this result will be 0, right? Now for a calculation of P2, check 2 bits and skip 2 bits. Remember this, check 2 bits and skip 2 bits. So check 2 bits in that D3 comes, so that is having 1. So let me write 1 here. Then skip these 2 bits and then check these 2 bits. So that is 1, 1. So 1 XOR 1. And then after that you need to skip these 2 bits. So further there is nothing. So 1 XOR 1 XOR 1. So that is 1 over here. Now let us calculate P4. So for P4, we need to check 4 bits. So along with P4, 4 bits are this, and then skip 4 bits. So check this 4 bits means 1, 1, 0 XORing is there. So 1 XOR 1 XOR 0. So that is 1 XOR 1 XOR 0. That is 2 ones are there. So this will be 0. Then for a calculation of P8, we need to check 8 bits from here. But we have only D9. So P8, that is D9 only, right? And D9, that is 0 over here. So I can say this is 0 here. So here, if you observe this parity bits, P1, that is 0 over here, P2, that is 1 here, this P4, that is 0 here, and this P8, that is again 0. So this is my code word. So let me note down my code word over here. So code word over here, that is 0 0 1 1 0 0 1 1 0. That will be the code word that I'll be going to transmit, right? As if you have data that is this. So that is how we can generate code word. Now, very essential part that I'm going to explain you. That part is there based on what will happen as if you receive code word along with error. So you see here in question, we are receiving this data, right? Here we are receiving this data, and you see the code word which we have generated, that is 0011001110. But if you observe here, 1 bit error is there. This 1 bit error is there. Now, how we will be identifying there is error? The reason is receiver will be receiving data from channel. So obviously there is a possibility of error. So what will happen as if error is getting added with this? So by Hamming code, we can resolve this. Let me show you how. So here, again, what we will be doing is, we will be doing same process. Here we have received this code word, right? So first of all, what I will be doing is, let me write down this code over here. With this Hamming code, we are having total 4 parity bits. So now you see in shortcut way how to mention parity bits. So here you can say this is parity bit 1, then 2 to the power 1, so that is P2, then 2 to the power 2, that is P4, then 2 to the power 3, that is P8. So directly even you can write it. Like if you have code word, then if you want to note down like what is the position of parity bits, then directly you can write it like this. 2 to the power 0 means P1, 2 to the power 1 means P2, 2 to the power 2 means P4, 2 to the power 3 means P8. That is how directly we can note parity bits. But if you want, you can calculate that in this way, as I have explained you, condition, and then you can say that is how 4 bits are there, and then you can note it down as per position, and then you can write all those things, right? Now, obviously these are the parity bits. So you can say these are my data bits. So this will be D3, this will be D5, this will be D6, this will be D7, and this will be D9, right? So that is how parity and data bits that we are having now. Now we need to see whether received parity is correct or not. So let me show you how to identify that. So here parity P1, let us check it for parity P1. So that calculation is same as I have shown it previously, right? Check 1 bit, skip 1 bit, check 1 bit, skip 1 bit. So see, check 1 bit, then skip 1 bit, right? So check 1 bit, that is 1, then XOR, skip 1 bit. So check 1 bit, that is 0, skip 1 bit, check 1 bit, that is 1, skip 1 bit, check 1 bit, that is 0, right? So that is 0 only, right? 2 ones are there, so that is 0. Now for P2, check 2 bits. So for P2, check 2 bits, right? So if you check 2 bits, in which P2 that you need to ignore. So check 2 bits, that is having D3, that is 1. Then skip 2 bits. So you need to check these 2 bits, that is 1 1. So 1 XOR 1. Then skip these 2 bits. Then again check, but here we don't have bits. So you can say P2, that is 1 XOR 1 XOR 1. So that is 1. Now let us see it for P4. So P4 is having check 4 bits. So just ignore P4 and check 4 bits like this. So check 4 bits. So that is 1 XOR 0. So here 1 XOR 1, that is 0, and skip 4 bits, right? So now P4 is there with us, and for P8, check 8 bits like this. So here we just have 1 bit over here, that is D9, that is 0, and skip 8 bits after that, right? So you can say this is 0. Now you need to see which parity are correct and which parity are false. So here if you observe P1, so that was 0 and that is 0 over here. So this is perfectly correct. If you observe P2, so that is 1, that is 1. So this is also perfectly correct. If you see P4, so P4 is 1 over here, but P4 is 0 over here. So this is false. And if you observe P8, so P8 is 0 over here and P8 is 0 over here. So this is also correct. So here what you can say is, you can say this P8, P4, P2 and P1, that is having, you see which order. P8 is correct, then false, then correct, and then correct. So correct should be having logic 0 and false should be having logic 1. So false is having logic 1, correct is having logic 0. So P8, P4, P2, P1, that says number is 4. 0, 1, 0, 0 means number is 4. So this parity indicates bit number 4 that is having error. This parity indicates bit number 4 that is having error. Now if you observe, you see 1, 2, 3, 4. Fourth bit is having error. You see, I have explained you that this is what the code word which we have generated. And in this, at receiver side, this 0 is getting converted into 1. And that is the fourth bit. So you see, here as per calculation, we are having idea about fourth bit is having error. Remember, you will have to check which is correct and which is false. So correct should be having 0 and false should be having 1. And based on that, this is 0, 1, 0, 0, P8, P4, P2, P1. That is how ordering will be there. And fourth bit that is having error, that is been indicated by this parity bits. So now receiver is having idea about there is error in fourth bit. There is error in fourth bit. So what will happen? You see. So receiver will be generating error syndrome. Receiver will be generating error syndrome. So in error syndrome, what receiver will do is, receiver will place bit number 4 is equals to 1 over here, and it will keep rest bit as 0, right? It will keep rest bits as 0. Now one more information that will be there with receiver. See, receiver will be having received data, right? So receiver will be doing what? Receiver will be doing XOR operation with received data, right? And what is that received data? That received data is 0011101110. So let me note it down over here. So now receiver will be doing XORing of this, and receiver will be having corrected data over here. So corrected data will be 000, 000, 011, 011, 000, 110, 011, 000. Right. So if you observe, this is what the data which was generated earlier. If you observe, you see same data that we have generated earlier. So this is how Hamming code can detect error and it can correct error, right? So in machine based on this parity bits, error syndrome will get generated, that will get added with received data, and automatically receiver will be having corrected data. And receiver also having idea about, see, this 1, 2, 4, 8, these bits are parity bits. So it will discard these bits, right? And it will take this 9, 7, 6, 5, then 3, this bits as a data bits. So receiver is having exact idea about how we can detect error and correct error. I hope you have understood this. Still, if anything that would like to share it with me, please note it down in comment section. I'll be happy to help you. Thank you so much for watching this video.